The introduction of this scientific paper discusses the importance of responsive fluorescent materials for various applications such as sensing and bioimaging. The authors aim to investigate new concepts for these materials and expand their potential by encapsulating a non-fluorescent zinc complex into block copolymer micelles to create brightly emissive materials. The introduction highlights the advantages of using self-assembled materials for encapsulation, as they provide nanoscale confinements that can be tailored for specific applications such as drug delivery or storage of reactive molecules. Additionally, nanocontainers can function as optical sensors due to their high sensitivity towards the properties of their environment, including polarity, viscosity, and concentration-dependent effects. The authors note that most previous studies on nanocontainers have focused on using them as passive confinements for photoluminescent compounds, rather than actively modulating the emission. They mention examples where fluorescent building blocks or surfactants were used, but these approaches require intrinsic fluorescence and external stimuli for modulation. In this study, the authors propose a different approach by using block copolymers as both the building units for micelles and the chemical stimuli to activate the emission of a latent fluorophore. Specifically, they utilize polystyrene block poly, 4-vinylpyridine, PSBP4VP, D-block copolymers as hosts for functional complexes through micellar self-assembly. The authors mention previous work demonstrating the incorporation of switchable iron and zinc complexes driven by the coordination of pendant pyridine units in the P4VP block. The authors then describe the coordination-activated emission of Schiff-base zinc complexes, where stacking in non-coordinating solvents results in no emission, but coordination-induced destacking leads to a turn-on of strong green emission. They propose transferring this concept to micelles, creating fluorescent micelles from non-fluorescent hosts and guests. Overall, the introduction sets the stage for the study by discussing the significance of responsive fluorescent materials and introducing the novel approach of using block copolymers to create fluorescent micelles. The authors provide a clear motivation for their research and outline the goals and objectives of the study. In this figure, the authors present the results of dynamic light scattering (DLS) and transmission electron microscopy (TEM) measurements on the PSBP4VP-BCP micelles. The hydrodynamic diameters (DH) and core diameters (dcore) of the micelles were determined using DLS and TEM, respectively. The authors prepared empty micelles from 3 different PSBP4VP-BCPs with varying compositions but comparable overall molecular weights. They found that the hydrodynamic diameters, dH, of the micelles varied only slightly, ranging from 150 nanometers to 170 nanometers, irrespective of composition or complex load. In contrast, the TEM measurements revealed a significant dependence of the core diameter, dcore, on the weight fraction of the insoluble P4VP block for all micelles. The micelles with lower weight fractions of P4VP had smaller core diameters, while those with higher weight fractions had larger core diameters. The authors also noted that the incorporation of ZN-L did not alter the morphology of the micelles, as all micelles remain spherical. The authors concluded that the composition of the PSBP4VP-BCPs significantly affected the core diameter of the micelles, while the hydrodynamic diameter remained relatively constant. In this figure, the authors present photographs of solutions of the S52V42 and S58V42 BCPs in toluene after heating under reflux for 10 minutes. The samples were photographed under both daylight and irradiation with lambda x equals 365 nanometers. The authors observed that the solutions of S52V42 BCP in toluene did not exhibit any significant emission, either under daylight or upon irradiation with UV light. In contrast, the solution of S58V42 BCP in toluene exhibited a strong green emission upon irradiation with UV light. This result indicates that the incorporation of ZN-L into the micelle core resulted in a drastic enhancement of the emission, making the composite highly emissive. The authors suggest that this enhancement of emission is due to the coordination-induced emission of ZN-L within the micelle core. In this figure, the authors present the absorbance, emission, and fluorescence excitation spectra of the PSBP4VP-BCP micelles with ZN-L in toluene. The absorbance spectra of the micelles in toluene show two main absorbance bands at lambda equals 458 nanometers and lambda equals 482 nanometers, which closely match the absorbance behavior of neat, Zn, L, in pyridine. This indicates that the micelles effectively incorporate Zn, L into the core. The emission spectra of the micelles in toluene exhibit a strong green double peak emission, with the emission maximum at lambda m, max equals 509 nanometers. This emission is attributed to the coordination-induced emission of Zn, L within the micelle core. The fluorescence excitation spectra further confirm this emission behavior, as they closely match the fluorescence excitation spectra of neat, Zn, L, in pyridine. The authors also observed that the emission intensity and quantum yield increase with increasing weight fraction of the insoluble P4VP block in the micelles. This correlation suggests that the emission properties of the micelles can be tuned by adjusting the composition of the BCPs. The study investigated the encapsulation of Schiff base like zinc 2 complexes into micelles formed by polystyrene block poly 4-vinylpyridine, D-block copolymers. The micelles exhibited enhanced emission with high quantum yields and thermal stability compared to the neat complex in pyridine. The micelles demonstrated responsivity towards changes in the medium and pH, allowing for the development of a turn-on emission sensor material. The findings highlight the potential of these micelles as multifunctional platforms for fluorescence-based applications. If you are an author or copyright holder for the work presented in this video and you have any issue with the existence or contents of this video, please let me know.